Hi, here's some practice problems for concentration. All right, we've got parts per million first. And for parts per million, it is just the mass of what you start with, which is 10 to the negative third. That's the solute. It's dissolved in 1,500 grams of water, and you multiply that by 10 to the sixth. That's a pretty common solution or parts per million problem. So 7.5 times 10 to the negative third divided by 1,500 times 10 to the sixth equals 5. So 5 parts per million for the label there. Next one is 20 milligrams of mercury. Notice it's in milligrams, so you gotta have to convert your milligrams into grams first. That's 0.02 grams. And it's in, what's that, 19,000 grams of water, 1.9 times 10 to the fourth. And then multiply that by a million. So 0.02 divided by 1.9 to the fourth times 10 to the sixth. Got 1.05 parts per million. So this one is rearranging the equation and starting with 35 parts per million here, and we want to know the mass of the solute, so it would be X, and its whole thing's in 400 grams of water times 10 to the sixth. So just rearranging and plugging in the equation, solving for the amount of solute. So to solve for this, you would multiply both sides by 400, and then divide by 10 to the sixth. So 0.014 grams. Let's see. Want it to be milligrams though, so that'd be 14 milligrams. So X equals 0.014 grams, which is the same thing as saying 14 milligrams. Okay, next one's percent composition. You gotta read these slowly. It's 20 grams of solute in 135 grams of solution. That one's a straight up problem because this says solution and not water. So 20 grams divided by 135. Whoops, that's 135 times 100. So 20 divided by 135 times 100 is 14.81%. Next one, percent concentration by volume for 45 milliliters of methanol, 45 milliliters, dissolved in 575 milliliters of solvent. So it says solvent there, you gotta add solvent and solute to make the total volume, to reflect the total volume. So you take 45 plus 575 for your denominator, which is 620. So then times 100, and 45 divided by 620 equals times 100. So we're going to call it 7.26%. And we don't need to worry about this one. So we're on to molarity. Molarity problems, you have to use molarity equals moles per liter. And if you want, you can also use the triangle, moles on top, molarity and liter down there. So like, for example, in this problem, you don't have anything for grams, but you can solve for moles first by taking your volume, has to be in liters, so 0.35 liters times 1.2 molar. That equals 0.42 moles. And then you want your answer in grams. So to get it into grams, multiply by the molar mass of AgCl. Silver is 107.9 plus 35.5. It's 143.4. And if you multiply those two together, you get about 60.23 grams of silver chloride. Next one, how many grams of silver chloride are required? So same kind of problem. You're looking for grams, you gotta find moles first. It's 0.9 moles, or sorry, 0.9 molar times, again, this 350 should be in liters, so 0.35 liters. So 0.9 times 0.35, 0.315. That'll be moles. You want your answer in grams again, so take your 0.315 moles and multiply by the molar mass, which we just found to be 143.9 grams per mole. Times 143.4. So 45.17. Finally, more. So more molarity problems here. 0.75 grams dissolved to make enough 20.5 milliliters of solution. This would be a triangle problem again. Moles, molarity, and liters. Not molarity, so it's moles per liter. So take your 7.5 grams of sodium chloride and convert that into moles first by dividing by the molar mass, which is 58.5 grams per mole. So 7.5 divided by 58.5 is 0.128. Now you can divide that by the liters. So that divided by the liters, it's 20.5 or 0.025 liters. Sorry, 0.0205 liters. So I got about 6.25 molar. Next one, 50 grams of lithium sulfate are dissolved to make 200 milliliters of solution. So convert your 50 grams of lithium sulfate into moles. Lithium is 6.9 plus 32 plus 16 times 4 for oxygen, 109.8. So convert to moles first. 50 divided by that answer is 0.46. And then divide by the amount of liters it's in. 200 milliliters is 0.2 liters. So divide by 0.2 and you get 2.28 molar. Finally, you get dilutions for the last problem, our last set. And dilutions is M1 times V1 equals M2 times V2. So when it says what volume of 12 molar solution, I would have 12 molar here, and volume I'm looking for to make a 750 milliliter 0.25 molar solution. So 0.25 is the new molarity, and it's 750 milliliters. If you keep it in milliliters, your answer just spits out in milliliters. So take 0.25 times 750 divided by 12, and you get 15.625. 625 milliliters. All right, so next one, 12. If I leave 1,000 milliliters of 0.75 molar sodium chloride solution uncover on a windowsill and 350 of the milliliter evaporates, what will the new concentration of sodium chloride be? So this would be 1,000 milliliters, 0.75 molar equals 350 milliliters solve for M2. So you would take 1,000 times 0.75 divided by 350 and get 2.14 molar for new molarity. And finally, start with a solution of 900 milliliters of 0.25 molar solution sulfuric acid. You heat it and it changes its volume to 1 liter. What's the molarity of the solution after heating? So it'd be 900, that's not 900, times 2.5 molar. And this is in milliliters, so I want to change this one into milliliters, so keep it as 1,000 milliliters and solve for M2. So that would be 900 times 2.5 divided by 1,000 and get 2.25 molar for your new concentration. So there is a quick run through of different types of concentration problems. Happy studying. Bye!